Okay. So if you got these two functions, anything that you could do with, numbers themselves, you can do with the functions. Okay, so you can add functions. And here's the notation for that. F plus g of x. And you do exactly what it says. You take f of x and you add it to g of x. And then you simplify as much as you can. Which wouldn't be much on this one. We just combine our numbers. We have x squared plus 2x plus 4. Okay. So if I said, what is f plus g of x? You'd say this is f plus g of x in the red. You can subtract them. Either way. F and g, when you add them, remember adding is commutative. So if I said what's g plus f of x, it'd be the same thing. Subtraction is not commutative, so you're going to have two different answers here. Okay, because if you take f, that's your positive one, you're subtracting g, so you have to make it minus. So the big thing here is make sure you remember your parentheses. That way you'll remember to distribute your minus sign. So f minus g would turn out to be negative x squared plus 2x minus 2. And g minus f would end up being x squared minus 2x plus 2. Okay, so you're going to get different things. Subtraction, you can't switch spots and get the same thing. You can multiply, so here's the notation for that. F times g of x. Make sure when you multiply you put parentheses around each function. Okay, because now we're going to have to distribute this out. So we get 2x cubed plus 6x plus x squared plus 3. And then we'd want to switch spots, because we always want your powers to be in descending order. So that's what f times g of x would be. What would g times f of x be? Same thing. Multiplication is commutative. Okay, you can switch the order. Same thing. You can divide. So if you divide, I would just leave it like this. You end up with a rational function. If you look at all these other ones, okay, everything except for the divide, whatever domain restrictions you have on either one of these, they're going to carry through. Okay, so if I had a domain restriction, okay, which I don't on these, but if I had a square root in here, whatever makes that negative is going to make f plus g of x negative. Okay, so I'm going to have that same domain restriction is going to follow through. The same thing will work for divide. Divide will have the same domain restrictions as the original function, but because I'm ending up with this, I'm also going to add in some new domain restrictions, because this can't be 0 now. Okay, you might add on top of your original domain restrictions. Then there's composition of functions. So the way this is read is f of g of x. So I'm starting with my f function. My f function is 2x plus 1. I took this x out, and in its place I put g of x. That means I'm going to take this x out, and in its place I'm going to put g of x. And that's how composition works. You're substituting g of x into the place of x in your f function. If it's g of f of x, that means I'm going to look at my g function, and in place of x, I'm going to put the f function. Okay. So if I simplified this one, it would be 2x squared plus 7. Okay, because I just distribute. When I simplify this one, I'm going to have to square this out first. Okay, so make sure you don't break the rule that's on the don't board. Don't distribute this power across the plus. You're going to have two of these things. So if you guys still need to do it this way, you need to write them both out in order to square it. Or if you guys remember the pattern, you're going to take the first thing squared plus 2 times the first thing times the second thing plus the second thing squared. Okay, so you'd end up with 4x squared plus 4x plus 9 plus this 3 that's hanging on the back. It makes it a 12. Oh wait, I squared the wrong thing, didn't I? There should be 1 plus the 3 is 4. So that's composition of functions. Composition of functions, same thing. Whatever your domain of f and g are, those carry through. So if g has a domain that doesn't allow x to be 0, f of g of x won't allow x to be 0. Even if it looks like that restriction has been nullified, it carries through. Okay? So maybe in your original function, there was an x on the bottom, and that's why x couldn't be 0. And when you do composition, maybe that x cancels out. That domain restriction still applies. Okay? Because even though it looks like 0 would work in there, and it would if you did it the straight way, this function is coming from this. Okay? You're doing g of x first, and then you're putting it into f of x. So whatever you can't put into g of x, you can't follow it through and put it into the f of g of x. I think I have one. I'll make one there. Let's see. Let's say f of x was let's see. 2 over x and g of x was x to the negative 1. Okay, so here's my two functions. So if I do g of f of x, I'm going to put this f of x inside my g of x. So I would have 2 over x to the negative 1. If I simplify this negative 1, I could distribute it in there. 2 to the negative 1, x to the negative 1, and then they switch spots. So you get x over 2. X can't be 0 here. But really, it could be now. But since it couldn't be back here, my domain still would not allow x to be 0. Okay? Yep. So simplified version retains the domain restrictions. Let's see, these are just more examples. I think we'll skip these. Okay, if you've got a number that you're putting in, this took the place of x. So I'm going to put it in for all my x's that I would get when I do my f of g. So you guys can do it after you combine it or before. So let me bring my f and g down. Okay, so if you want to, you can put this 2 in right away for both of these. Okay, because f of 2 equals 4 minus 3, which is 1. G of 2 equals 2 squared plus 1 is 5. And then you can just add those together. Okay, so that would mean this would be 6. Okay, you can do the same thing. I'm going to make these all 2. So I have to do the same thing over and over again. Okay, so instead of doing all that mess with the multiplying and distributing and stuff, just put them in first, and then take f times g. So this would be 5. Okay, take f minus g, that would be negative 4. G divided by f. 5 over 1 is 5. Okay, so it's a little easier when you've actually got a number to put in. When you're doing composition that way, it's a little bit different. You need to take, so there are 2. You need to take the g of 2, which was 5, and put it into the f. So you're going to take the output from this one and put it in as the input for your f function. Okay, because you're evaluating this first. Okay, you do your inside parentheses first. G of 2 is 5. So what's f of 5 is what this really turns out to be. Okay, because g of 2 equals 5, so really this is f of 5, because that's what g of 2 equals. F of 5 would be 7. So you get 7. Okay, you guys done this stuff before? No? Maybe you don't remember it. Okay. Let's see. What time we got? Alright, we'll just hang it up. We'll try those.